Hi my friends, let's try to model this part number 20, hydraulic elbow, from my collection of 100 parts. If we take a look to the drawing, we see that there are two revolution features and also two holes. We start by creating the external volume, and in the final we create this to hollow inside. Yes? Let's start as usual. Now we have a procedure for this. This is a thread for pipes, gas 1/4 inch, and we'll find how to create. Then other cylindrical parts with diameters of presented here. You have to memorize them because I start to make this part. The total length is 25. Okay, so some lines, and close. This line is center line. The total length is 25, and now the scaling is okay. This is a diameter. Let's create also the clearance here to have no problem in the future. Trim this and extend this by pressing shift, as I told you several times. The distance from the center point to the right end is 18. I want the other axis to be on the vertical of the center point. Then a diameter of 11, another one of 10.5. Distance is 9. This and I move this here, and another dimension is 2 millimeters. Okay, this is not created because I want to show you how to find this thread to apply. This would be this dimension. The other is because I didn't apply the coincidence here. This one dimension I'll present you right now when I create the revolve. Okay, I can also add the ends, 0.5 at 45 degrees, 1.5 at 45 degrees, 1.5 here, plus 0.5 at the other end. Now if you want to find out what is this, in order to dimension correctly this cylindrical part, to apply a thread, you have to open the Windows Explorer and right here this path of your computer. If you have another Inventor, change here with the year, and if you apply enter, you find this directory with data, Office Excel file, which can be opened to see this. This is the general table in Inventor with all threads, and if you go to DIN pipe threads or BSP, this is Deutsche Industrie Norman, this is British Standard parts. Let's go here because the British invented this kind of thread. I choose this line because this is the proper fillet, the proper thread for us, which has the major diameter 13 millimeters. I copy this, I go back to our part, to the sketch, and I place this diameter here. Yes, the one I copied there. Copy, paste. Okay, this is the diameter. Finish. And now I apply thread for this surface. ANSI, not ANSI, but ISO pipe threads. You see here dimensions which are appropriate for this kind of thread. Okay, now you know. Next is the other cylindrical part, which has dimensions of 10 with 5.5, and we'll stop it here. 12 is important for us. 10, 12, 8.5, 5.5 are our useful dimensions. We create a new sketch in this plane XY, and here we draw F7 to see inside. We draw some lines. This is the final and close. Yes, we have to ensure that they are fixed. This is center line, and now dimensions. You remember 12. You remember the diameter of 10. and also diameter of 8.5. Good. One dimensions needed. Which one? This one. 5.5. Yes? 5.5. Good. Finish sketch. Revolve. This is to be joined with the former volume. Okay. It has chamfer, two chamfers. There is another chamfer here, we forgot it. Yes, 0.5. 0.5 here. All are 0.5. This one, and this one. Let's apply them. Chamfer 0.5 is already selected, also here, also here. Okay, there is a channel here, but I prefer to start this hollow cylindrical or revolving shapes. Look here to the principle, 20 degrees at 8.5 diameter, continue with 5 diameter to the center point. The center point of our part is here. Always you have to remember where is the center point. This is its position, and you choose this looking to the drawing. Okay, the conical part is directed by the angle and this diameter, and the hole is to here, not to here. 18 is a dimension, but we add half of diameter of 5. Yes, 18 plus 5 divided by 2. Let's create the same plane with another sketch. F7 line from the midpoint up, angle, and go inside. No, I'll make this as a hole with distance. Dimension, let me convert this to center line. Dimension 8.5. (20° is the conical, then 20 divided by 2 is a side. This is to be placed anywhere, even at the center. It is better to have a point in the part. Yes. Finish sketch, revolve, select profile. This is the profile. Select axis is selected and cut. Okay. Now we have to apply a hole, and be sure you select this face, because this is the face from which we'll measure the depth of this hole. Yes, and this is anyone is the diameter. The diameter of the hole is 5, and the length from here, from the face, is 18 plus 5 divided by 2. Okay, you see the hole. On the other direction, we don't need to create a sketch. We apply another hole of 5 millimeters, but with the depth centered here, with the depth of 12 plus 5 divided by 2. Okay, F6. It seems to be finished, but there is another combination of one chamfer of 0.5 again, and the channel. This is the channel with a depth of 2 and the dimension of 3.5. This channel. Let's create it in a sketch on XY plane. F7. You see inside this combination, this is the real intersection between cylinders with the same diameter of 5 millimeters. And we project this line to create a rectangle from it to center on the vertical, the same vertical, the midpoint with the center point, and dimension 2 millimeters and 3.5, and the width 3.5. You see that everything is fulfilled, extrude, symmetrical, cut all the way. Okay. Yes, this is our new part finished. Okay. The most important thing here was how to find this diameter for applying the thread. But I see that this is not on the right, it's on the left. You see? You see? Double click on this feature and let's select the other option, right hand. We want the thread to be on the right, to the right, yes? When is nothing mentioned, then it must be on the right. The material is, of course, steel carbon, and we choose again antique with this very well machined. Let's machine also this, and also the other with the titanium polished aspect. Yes, it seems to be a proper aspect. I wonder if I choose here this aspect, what happens. Let's try. titanium polished. No problem. It's very nice. The data, $18 grams. 18 grams. It is a small part. That's all for today. Bye bye.